Welcome to Sustainability in Your Ear, the EARTH911 podcast, and I'm honored to be joined again by Peter Fiekowsky, who is the director and founder of the Healthy Climate Alliance. Check him out at healthyclimatealliance.org. Peter, last time we spoke, you talked with us about ocean iron fertilization as a way of capturing carbon and sequestering it in the deep ocean. This time we want to talk about direct air capture, which is a new technology, or technology that's certainly coming to the fore and being talked about a lot more. What is direct air capture of carbon dioxide?
Great. Well, Mitch, thanks. It's great to be on again. So direct air capture of carbon dioxide is a method of concentrating the CO2 into a pipe with which you can do something with that CO2. Mm-hmm. So if you want to bury the CO2, you've got to concentrate it. And direct air capture is a standard way to do that. And there are a range of methods, and I'll let you ask questions to get down to it.
So there are several methods, and I've been reading a lot about this since we first started talking. And the two most common seem to have to do with the amount of humidity in the capture medium. Either you can have a wet thing, expose it to carbon dioxide, dry it out, that releases carbon dioxide, or conversely, you could have a dry thing that captures it, and by making it wet, it releases the carbon dioxide. Those two forms of direct air capture rely on moving that material into a confined space where it can release it and be captured in the pipeline like you were talking about. How do those work generally? Where would you find that kind of an installation in a world where we were doing direct air capture? Would it be just anywhere, or would it be in specific parts of the country?
Well, let me just expand a little bit on what you said.
Sure.
There's a number of processes which are purely chemical. So they're wet chemical, and you essentially bubble the air or exhaust from a power plant through a solution where the CO2 is absorbed chemically. And they do more chemistry on it such that eventually the CO2 is emitted in a pure form. Mm-hmm. And then there are two general methods using either amines or resins which absorb CO2 at room temperature and humidity. And then you can either heat it up, and the heat will release the CO2 from the surface, or use water and other chemicals. The water will displace the CO2 and it will emit it. And so the water methods are lower energy, and they work great in low humidity areas. So in the desert, of course.
Okay. So you picked the right technology for the environment you're in.
That's right.
One of the things that I've seen is looks like the world's largest window fan. It's just a bank of fans. Is that something? Is that just a design that's out there, or is that something that's real? Will we see these banks of fans along the side of the freeway capturing our carbon dioxide?
Not likely. Okay. In our imagination, I believe the picture that's shown very frequently was done with Photoshop. But I don't know that for sure. And either way is fine. I use that picture a lot because it wakes up people's brains.
Sure.
When they see the picture, they say, "Oh, I get it. You're actually pulling CO2 out of the air." The method that I happen to be most friendly to is the humidity swing, and it's been promoted by Klaus Lackner down at Arizona State University.
Right.
And he's designed it so it just uses the wind, because he figures if you have to power fans, that's going to use up a lot. That could use up a lot of power. If you design it so just the native wind is enough, then the energy consumption goes way down.
Well, now there was an article in Science a few weeks back that essentially concluded that they had overestimated the cost of direct air capture pretty dramatically. And they're saying that we can go from $100 a ton of carbon dioxide captured to as little as $20 by 2025. Is that dependent on funding? How do we get to that level of efficiency?
Well, it's like any manufacturing, that the more you build, the lower the price goes. Solar panels are a good example of that. They started out 30 years ago or 40 years ago. I don't remember the number, $200 a watt or something,
Yep.
$500 a watt. And now it's $1 a watt and down to 30 cents a watt. And it's a matter of the more you make, the better you get at making it. What's nice?
Go ahead.
What's nice about things, again, like the lacquer method, is it really has very few moving parts. So getting the price way down is highly likely. That doesn't look like it'll be expensive in the end.
So scale answers that question. You do more of it, you get a cheaper output.
And there's one other aspect, and that is the energy. So you do need energy to release the CO2 from whatever the substrate is. Mm-hmm. In most cases, you can just use waste energy from the factory, from a power plant. But there's a lot of waste heat, which is free, and that's a big cost saving.
Well, but on the funding front, there are, and one of the arguments about carbon capture is that it needs some funding from the United States government to really get this going. There's two bills in the Congress, the Future Act and the Use IT Act, which would ostensibly provide some support for this research. Should EARTH911 listeners be calling and writing to their representatives asking them to support those bills in order to see this happen?
Well, I'm not familiar with those bills in particular. Mm-hmm. They're probably not going to pass in this Congress. Most of those bills get Congress familiar with the language and with the idea and then get passed in future Congresses. Right. We may have a more progressive Congress in the future, in which case the things will change. For now, the biggest thing that I would call on listeners to do is to think about the outcome. What we want to do is get the carbon out. And the most important thing is to realize that we have to do 1 trillion tons of it.
When you say 1 trillion tons, that sounds completely overwhelming. But you have a goal and a plan to get us to this by 2040 to 2050.
Right.
When do we need to start in order for that to happen?
Well, we should start as soon as possible. We're losing species every day, and those species won't come back. New ones will, of course, eventually take their place. So every day we wait is a species lost, so to speak. And then the question is, what's the action to take? And the main action to take is to focus our climate work on restoration. Mm-hmm. That up until now, we've been focusing on mitigation, on reducing emissions. And most of the carbon dioxide removal projects have been focused on trying to get to the point where they're canceling out current emissions. Right. Which is great, but it's a factor of 10 scaling difference. And whenever you have a factor of 10 difference in scale or technology, then you generally have a totally different view. You get a different set of solutions. And so the first step is to focus on restoration, because then people will focus on the solutions that make the biggest difference.
So let's talk just very briefly about the physical impacts that people would see if we did get the carbon level back to pre-industrial levels. What would happen to the world?
Man, you just say that and I'm smiling.
Well, I hope you're smiling for a long time, Peter.
Yeah. Well, so when we get I'm not going to say if, I'm going to say when, because there are a lot of us who are committed to doing this and we're not going to stop until we're done. When we get the carbon back down to 300 parts per million or below what it was when our species developed and when our civilization developed, then we'll find that the glaciers will stop melting, sea level will stabilize. But best of all is some of these horrible floods and fires and extreme weather conditions will stabilize. And it means that agriculture will be easier. We won't need to install air conditioning up in Alaska and things like that.
And we won't need to spend so much money on insurance for things that are truly devastating and can't be paid in any other way than sharing it across society. Yeah. So that raises an interesting question. And we've talked about this before. People have resistance to carbon capture because they believe that it might, well, some people believe that climate change isn't happening, and hey, good for them, but let's ignore them for right now. But there is another group of people who say if we don't focus on other aspects, such as carbon emission reduction or reforestation, that we will be missing something. And I don't think that anyone is suggesting one solution is going to be right, but there is a tendency to say, if you adopt that one, my solution won't get the same attention. So we're contending over this, even though, in fact, everybody is aiming in the same direction. What's the right tool mix, in your opinion, and what's the benefit of that mix in terms of carbon capture?
Well, I like how you started that, that there are people who say we shouldn't do carbon capture at all because that doesn't reduce emissions. And what most people think and hear about the climate is that our main goal is to zero out net emissions.
Right.
And that's a good thing, I'm sure. I mean, that is a good thing, but that doesn't fix the climate. That just reduces emissions. And most of us really want to restore the climate. We want a climate that our children will survive and thrive in. And to do that,
and the trillion tons will still be there even if we stop.
Exactly.
Right.
And so the number one thing is to change our goal to restoration, because once you do that, all the objection to carbon removal goes away. The people who've objected over the decades to big carbon removal projects, they've been taking literally what the UN says about climate and reducing emissions and complaining that these various projects don't reduce emissions. They have good intentions, but we wish they didn't take the UN quite so literally.
Well, and that kind of comes down to what you're going to measure and how you're going to determine whether or not you're success. And right now we ask people who are working on reforestation, which, ostensibly should be focused on increasing diversity,
yes.
Animal and species diversity, to also be concerned about the amount of CO2 that they're sequestering in their forest. So we can sort of take that off their shoulders, it sounds like, by pulling the carbon out of the environment, continuing to do the carbon emission reduction, and really let them be foresters rather than carbon specialists.
Yes. Yeah, that's one thing I've seen in the last few months as I've talked to a wider range of activists, that as we get better at the technologies that will get the trillion tons out, and that's, as I said, mineralization on land and photosynthesis in the ocean. Those are the two things that can quite easily hold the trillion tons that we need to remove. Once we say that we can do that, that frees up forestry and soil management to do what they're really intended to do, which is enhance the environment, increase the diversity, make the biome more stable, and so on.
So a broad mix of tools is something that we should encourage people to think about, and keep in mind that no one answer is going to dominate all the others. It's about allocating across those various options. Now, you also, let's talk a little about what you get when you capture all this stuff. You've been working with, and I believe advising Blue Planet, which is an organization in San Jose. And what are they doing with their carbon?
So Blue Planet has a process that takes carbon dioxide and turns it into limestone. And they get calcium from various places. It's a long, complicated story, but there's lots of calcium around. And then that limestone is called aggregate, the gravel used in concrete, used in roads and buildings. And so their business model is to provide aggregate from basically at where it's needed, because the main cost of aggregate is environmental. It is that you have to ship it, and that it takes a lot of diesel.
Well, that also comes back to, you'll see these installations everywhere, because you're going to want to be relatively close to where the material will be put to use, so that you don't just put more greenhouse gas into the environment to get it there.
That's right.
Blue Planet is actually building the extended runways and they're providing materials for the extended runways and the new terminal at San Francisco International Airport. And when you walk past the building and you see this and you realize it's been made partly by what's pulled from the air, it's a really astonishing thing.
Yeah. And what's interesting about them is they started out, and their initial commercial plant opens up in a few months here in the Bay Area. And it uses CO2 from a power plant, from a large gas power plant.
Right.
And then we're working with them to develop a direct air capture process so that when they need to produce aggregate in places where there is no fossil fuel power plant or other source of exhaust, they can use the air. And it turns out, so far it looks like it's not going to be very expensive and still be profitable even when they're pulling CO2 straight out of the air.
So that, that raises it. There are a lot of other things that you can make with carbon. And one of the things I've been struck by as I look at the outputs of direct air capture is that, and even though they don't necessarily account for all of the carbon use we need to get rid of everything, but this is the foundation of our next economy. There are carbon nanotubes, carbon fiber, various, and what you need is pure carbon, which is what's left when you get done with this process. It seems like what we are talking about is turning our whole mining mentality inside out. And instead of looking at the ground and thinking, what can we get out of there? Looking at the air and thinking the same way about the range of opportunities that we have. But why then do people resist this? We happen to be speaking on July 19th, and earlier today, the House of Representatives in the United States voted 229 to 180 to endorse a concurrent resolution, which of course has no binding power at all. It's just advice to the president, that a carbon tax would be bad for the environment or bad for the economy. And that whole mentality gets pushed on to the question of should we do capture, should we do reforestation and otherwise, because there's the belief that it's all going to hurt our economy. And yet we just described raw materials for a new economy. How do we get past this? And I know you have years of lobbying experience around a variety of subjects. What's the best way to wake our representatives up to the fact that they are literally telling us not to take the steps into the future that could lead to a new economy?
The best thing is to make it clear to people that we have a pathway to a place that we want to get to. And I would say that the climate movement has been trying to avoid disaster. And so when you say that, what you picture is disaster. And that's a conversation nobody wants to have. And I can understand why some in Congress don't want to have that conversation, because who wants to talk about disaster? If we frame the conversation around giving our children the same healthy climate like our grandparents had, that's something people do want. And it's actually a conservative value that even progressives appreciate.
So a prosperity and quality of life argument is the right way to go, it sounds like. And this is a having been working with EARTH911 now for about 6 months, I'm really struck by the dichotomy between those who think that this is the end of the world and those who think that maybe humans, scrape by sometimes, but we do tend to find our way towards better futures. We simply need to be more aggressive about the positive outcomes that we can achieve rather than talking in terms of the negative impact of all the things that are happening. Because they're happening to us, seem like they're also out of our control. You've got a mechanism, and you've got a way to move us forward. Yeah.
What's interesting in the climate field, and in most fields, is often we use fear, or try to use fear, to motivate people. And if you study the neural system, you discover that neurons really don't have a distinction good and bad. Neurons have a distinction stimulus or no stimulus.
Yeah.
And so using a positive, putting whatever it is we talk about is what our attention goes on. If it's a disaster, our attention goes on the disaster. Right. And that's what our actions will be consistent with. And so if we want a good planet, we draw that picture, draw the bridge that gets us from here to there, and then people just naturally, without even thinking, it's just the lower brain, automatic, the way we're wired, takes us to that place that we're talking about. And hopefully we're talking about what we want rather than what we don't want.
Well, the place for people to go is healthyclimatealliance.org to find out more. Can you tell us a little about the organization and your goals and more wrap up?
Yeah, so our goal is to set a global goal of climate restoration. And we've been working with the UN, with the Vatican. I actually spoke with Pope Francis a couple of weeks ago. And working in Congress, we have a resolution that should be introduced in the near future saying that our climate goal is to give our children the same healthy climate our grandparents had. And we're, in addition to doing the advocacy work at the top leadership level, we're also working with the companies and organizations that are implementing it so that we can tell people climate restoration is possible, it's achievable, and it's happening right now.
Well, Peter, first off, I wish you the best of luck, and I'll be doing everything I can to help.
Thank you.
Well. And everybody do check out healthyclimatealliance.org. Peter's team is doing phenomenal work, and it's a full spectrum solution. We're not just talking about hopes, dreams, and regulations. We're talking about real business and prosperity as well. Yeah. Thank you, Peter, for joining us on Sustainability in Your Ear.
Mitch, thank you very much. It's a great pleasure to talk with you and your listeners.
Take care.
Thank you.